adventurer. This is your captain speaking. Firstly, let me commend you on your persistence and progress navigating through the world of complex numbers. You have almost completed this journey, and I'm thrilled to inform you that at the next checkpoint, you will learn how to divide and multiply complex numbers in polar form, a new approach to representing complex numbers as well. I hope you find this knowledge useful in your future endeavors. Thank you for flying with us today, and have a nice trip.
Many of you might have seen this letter multiple times before, like on math class when working with graphs or in the economy class, or this, claiming to be one of the most beautiful equations in mathematics. There's been a lot of jokes made from it, and today I'm going to be explaining to you what it really represents. And in the end of the video, you can proudly say that you have finally understood a math joke. At least I was. So with that, adventurer, let's begin. On my last video, I explained how complex numbers could be represented using the polar form. And for those of you who haven't watched it yet, this is how it looked like. The r represents the modulus or the length from that complex number point to the origin, and the theta is the angle rotated from the x-axis. We can make the polar form shorter by using what is known as the exponential form. And this is how it looks like. R multiplied by e to the power of I theta. And the exponential form is just a shorter version of the polar form. The proof for the exponential form is lengthy, so on my future videos in calculus, I'm going to prove it for you. With the help of the exponential form, we can use it as an aid to multiply and divide complex numbers in polar form. So, how do we exactly multiply and divide complex numbers in polar form? Let's assume that we want to multiply the complex numbers 3 cosine of 30 plus 3 sine of 30i, and 6 cosine of 60 plus 6 sine of 60i. Doing it straight like that could become an issue, as we have to multiply trig ratios with each other. To solve this, we are going to use the exponential form. Rewriting the polar form, we can get that the exponential form for it becomes 3 multiplied by e to the power of 30i multiplied by 6 e to the power of 60i. Now we can begin by multiplying the r's, so we get that it's equal to 3 multiplied by 6, which is equal to 18. And using the power rules, we can get that the exponents becomes 330i plus 60i, and that is equal to 90i. Simplifying everything, we get that the product of the two complex numbers in exponential form is 18e to the power of 90i. Converting all to polar form, we end up with 18 cosine of 90 plus 18 sine of 90i. And that is equal to 18 multiplied by 0 plus 18 multiplied by I, or 18i. To divide numbers in complex form, you have to... What's going on? I'm losing connection.